Second part of lesson 3 is looking at finding real zeros of polynomial functions. So we've already been finding zeros of polynomials, some quadratics, cubics, things like that that are real simple. But in this lesson, we're going to look at ones where you can't just do it by factoring. You've got to use synthetic division, which is what we practiced in the first part of lesson 3. So first thing we're going to look at is the rational zero test. So what this test tells us is all the possible rational zeros that we could have with each function. Rational means that they can be fractions, okay? So this is any number you can write as a fraction. So when we do this test, it'll tell us the possible zeros. Again, it's possible, not definite. The possible zeros we could have that are rational numbers that we can write as fractions. So the way you do this is you look at the constant term, take numbers that will divide into that constant term. Well, the only thing that goes into 1 is 1, all right? And you put whatever numbers will go into that over whatever numbers will go into the lead coefficient, which in this situation is also 1. So 1 over 1, all right? So all the options for the constant term go over all of the options for the lead coefficient. Now right here, there's only one of each. So the options are pretty small. 1 over 1 is 1. And on all these, they're always either positive or negative, okay? So each of these possible rational zeros can be positive or negative. So for this function, we only have two possibilities of zeros that are rational numbers, positive 1 and negative 1. All right. Now you go ahead, pause the video, and try to figure out all the possibilities for the function at the bottom of this slide. All right, so your constant term is 16. The factors of 16 are 1, 2, 4, 8, and 16. And then the factors of your lead coefficient are just 1 again. It's the only one you got. So you put 1, 2, 4, 8, and 16 all over 1. Of course, when you divide them all by 1, it gives you those same numbers again. But also, you got to remember the possible zeros are positive and negative. So your possible rational zeros are positive and negative 1, positive, negative 2, positive, negative 4, positive, negative 8, and positive, negative 16. So we have 10 possibilities right here for our rational zeros. All right, so now let's look at how we use this along with a calculator to figure out what our rational zeros are. So first, let's figure out what are the possibilities. So we've got factors of 3, which are, of course, just 1 and 3. And we put those over, all right, the factors of 2, which are just 1 and 2. All right, so we've got 1 over 1, which is 1, positive and negative. 3 over 1, which is 3. And then we've got 1 over 2. Right, remember, we got to put all the numbers on top over all the numbers on bottom. And then we've also got 3 over 2. All right, so right here we have 8 possibilities of rational zeros, because we could have positives or we could have negatives. All right, so now to figure out a place to start, what you want to do is graph the function on the calculator and look and see where the function is going to cross the x-axis at. So let's go to y equals and plug it in, 2x cubed plus 3x squared minus 8x plus 3. All right, we graph that. Now before you do this, you also want to make sure that there's nothing right up here that we could factor out of our function. So right here, of course, there's no greatest common factor. There's nothing that will go into each of these terms. So you want to check that first. But right here, once we graph it, we see it looks like it's crossing the x-axis at -3, which again is one of our possibilities, right? -3. It also looks like it might be crossing at 1 somewhere, but we're not sure about that. It's kind of close. So what I would probably do is try to see if -3 is a 0. Test it first. Okay, so finding the possibilities and looking at the calculator gives us options to test. So to test to see if we have a 0, we're going to do synthetic division. All right, if we want to see if -3 raises a 0 right here, because that's what it looks like it's crossing, and that's one of our possibilities, we're going to use -3 with synthetic division. Use your coefficients. We've got 2x cubes, 3x squareds, -8x's, and then 3x zeros. Remember, if there's one missing, right, if there's an exponent missing, you've got to put a 0 in its place. Bring down the 2. 2 times -3 is -6. 3 minus 6 is -3. Times -3 is positive 9. Minus 8 and 9 is 1. 1 times -3 is -3. And then 3 and -3 gives 0. All right, so when we see that remainder of 0, that tells us that -3 is most definitely a 0 of the function. Okay, so right here we're trying to find the real rational zeros. Well, we just found one. All right, so one of our answers is -3. All right, so let's see if we can find the others. You can continue doing synthetic division, or you can try factoring, because what's left now, since this was 2x cubed, what's left is 2x squared minus 3x plus 1. So we could try to go ahead and factor that using slide and divide, or you could do synthetic division again. If you see another possible rational 0 in your graph, then you could try doing synthetic division a second time. Let's go ahead and do factoring on this one. So I'm going to slide the 2 over. That gives me x squared minus 3x plus 2. Now, what multiplies to be 2 and adds up to 3? Well, 2 and 1. So we got x and 2, we got x and 1, and we're going to use a minus sign on both. Minus 2, minus 1. Now remember to go back and divide by 2. Since we slid by 2, we got to divide by it. 2 divided by 2 is 1, and then 1 won't divide by 2, so we put the 2 back in front of the x. So those 2 are the factors that are left. Now, to find the zeros of those, I can set each of them equal to 0. So add 1, x equals 1. Add 1, and divide by 2, so x equals 1/2. Okay, so those were the other 2 places right here on my graph that it was crossing, 1/2 and 1. All right, so when I look at my answer, my real rational, find my rational zeros, I've got -3, I've got 1/2, and I've got 1. So those are my 3 rational zeros. All right, so let's go ahead and you pause the video, give the U try down there, give a try, and I'll go over it, see how you can do on it. Let me know if you have questions. All right, so you guys got one and a lot of possible rational zeros because your factors of 45, there's 6 of those, 1, 3, 5, 9, 15, and 45, and you've got 2 factors of 2, 1 and 2. So you've got to put all 6 of those factors over 1 and all 6 of them over 2, which gives you 12 different numbers, positive and negative. So that's really 24 possible rational zeros, which is a lot. Now you can get a lot on some of these, all right? So there you can see them listed right there, all the possibilities. You get positive, negative, 1/2, 3/2, 5/2, 9/2, 15/2, and 45/2, and of course all those numbers over 1. All right, now when we graph on the calculator, we're looking to see which of those values does it look like the graph is actually crossing the x-axis at. And it looks like it's crossing around -1, and maybe over here at 3, and then maybe somewhere around 5. So we can try some of these to see if they will work. All right, so let's try -1 first. That looks like most reasonable option. Okay, so we go ahead and do synthetic division. Now we got -1, and then we do 2x to the 4th minus 17x cubes, 35x squareds, 9x's, and -45 with no x. All right, so bring down the 2 times -1 is -2, -17, -2 is -19. -19 times -1 is positive 19. And then we've got positive 19 plus 35 is 54. 54 times -1 is -54. Plus 9 is -45. Times -1 is positive 45. And those, of course, cancel out and give me my remainder of 0. Awesome. So I found 1 0. -1 is one of them. All right, let's go ahead and do synthetic division a second time now instead of trying to factor, because now we're just left with a 2x cubed. Okay, we've not got it down to a quadratic. If I put in my exponents, I would have this right here left because I started with x to the 4th. So let's go ahead and do synthetic division again. It looks like it crosses around 3. So let's try doing synthetic division another time with 3. Bring down your 2. 2 times 3 is 6. 6 and -19 is -13. Times 3 is -39. 15 minus 39, or sorry, 54 minus 39 is 15. Times 3 is positive 45. And then -45 is going to give us 0 as a remainder. So now we've got our second 0, which is 3. All right, now we can try to factor. If you wanted to try synthetic division again with one of these other fractions, looks like it's going between positive 1 and positive 2. So you could try to do maybe 3/2, or you could try doing the one that's out closer to 4, or was it 5? So maybe you could try 5, or you could try one of the other ones. Or you can factor. Let's go ahead and try factoring right here, see if we can get this thing to factor. Also, it's good practice. So we've got 2x squared left minus 13x plus 15. Also need to slide and divide, so bring the 2 over. All right, so we got 30, and what adds up to be 13? Oh, that's simple. That's 3 times 10. So we've got x and 3, and we've got x and 10. We're going to put a minus on both. Now we're going to go back and divide by the 2, because that's what we slid by. So we divide by 2. Of course, 3 doesn't divide by 2, so you need to bring the 2 back in front of the x. 10 divided by 2 gives us 5. Now we can set each of those equal to 0. And solve. So we add 5 and get 5. Add 3. and divide by 2 and get 3/2, which is what we expected. That looked like those were the 2 places it was crossing. So you say, well, if it looks like it's crossing, why can't we just use those? Well, it's not always going to cross those exact spots. When we get to ones where they're not rational, some of our answers will be square roots, and they'll be close to those points, but not exactly on them. So we can't automatically assume just because it looks like it's there that it's definitely those. So our other 2 zeros are 3/2 and 5. All right, so we got -1, 3, too far, and then 3/2 and 5. Those are our 4 zeros. All right, so let's roll on. Okay, so one thing that we can do to give us another clue about our zeros is called the Cart's rule of signs. So essentially this will tell us if we have how many positive real zeros we have and how many negative ones we have. So what we're going to look at is how many times the sign changes. So if you notice right here, this first term is positive. Well, from this term to the next term, it changes signs once. And then does it change to the next term? Yep, changes back to a plus. And then it changes to the next term, which is minus. So this changed 3 times. So here's what the rule tells us. How many times your sign changes, we know we're going to have that many positive real zeros, okay, or all the numbers, even or odd, below that. So this 3 is odd. So what are all the odd numbers less than 3? Well, the only other one that's less than 3 that's odd is 1. So we could have 3, right, or 1 positive real zero. Okay, we know we're going to have 3 zeros total. Okay, all 3 of them could be positive real zeros, or we could just have 1 positive real zero. But we know we're either going to have 3 or 1 positive. Now, as far as negative real zeros, what you want to do to figure out how many negative real zeros you have is rewrite your function, and every term that has an odd exponent, 3, x to the first, x to the fifth, x to the seventh, x to the ninth, anything that's got x to an odd number, change the sign on those terms. So we're going to change the sign on this term to be negative. Of course, 2 is even, so 5x squared is not going to change. 6x to the first, that one will change because 1 is odd. And then -4, that one doesn't change. Okay, the constant terms don't change. So now look at our signs. How many sign changes do we have? Starts with negative, doesn't change, doesn't change, doesn't change. Okay, so we had 0 changes. So we have 0 negative real zeros. Okay, so we have 0 negative. We know this graph is not going to cross the x-axis any on the negative side. Okay, so when we do our possible, if we did our possible rational zeros right here, where we put the factors of 4 over the factors of 3, we wouldn't have to worry about the negative signs on this one because we know it's not going to have any negative ones. It's 0 negative real zeros. So we could just put positive signs on all of them and not have to worry about the negatives. All right, so you guys go ahead and try to figure out the positive and negative real zeros, or possible real zeros of this one down here. Remember, to find a positive, you look for how many sign changes you got, and whatever that number is, it's either odd or even numbers below that. So if it was, let's say we had 5 sign changes, well then we would have either 5, 3, or 1 positive real zero. If you had 6 sign changes, you would have 6, 4, 2, or 0 positive real zeros. Okay, and then to find the negatives, you just change the signs on all the terms that have an odd exponent and look for the same thing. Look at how many sign changes you have, and that'll tell you how many negative real zeros you got. All right, so pause it and try to do this next one, and I'll go over it. Okay, so we see here, we count the sign changes on the original function, and we get 3 sign changes, which means we have 3 or 1 positive real zeros. Now go through and change all the signs on the terms that have a an odd exponent. So just change all their signs. So we're going to change the 5x to the third. We'll change that one to be negative, and then we'll change 8x to be negative. The others are all even exponents. So when we change those, now we count the sign changes. Well, it starts positive, changes to negative, and then it's negative all the way through. So we only got 1 sign change once we switch the signs. So that means we know we're going to have 1 negative real zero. We know for sure that the x-axis is going to be crossed once on the negative side by this function. Okay, so now let's use both of these tools to figure out all the real zeros. Okay, so find all possible real zeros. That means ones that are rational and irrational, meaning they could have a square root in them. So first thing we want to always do is look to make sure we can't factor anything out. Right, so right off the bat we see that this function, they all have x's, so we can take an x out. So let's factor an x out of this function. Let me drop my document count down a little bit, give us some room. So we take an x out, that's going to leave 10x to the third minus 15x squared minus 16x plus 12. So we factored an x out of every term. So now when we set each of these factors equal to 0, right, we know we're going to have x equals 0. We don't need to solve that. That's one of our zeros right off the bat. We've got 4 zeros, and we already found one of them right off the bat by factoring. So that's good. Now we can take what's left and figure out the possible rational zeros and Descartes rule of signs, use all that good stuff to help us out. So let's figure out what our possibilities are. Factors of 12 are 1, 2, 3, 4, 6, and 12. We've got a lot of choices that will go into 12. And then factors of 10, 1, 2, 5, and 10. All right, so this is going to be a lot of options, right? We've got 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. And they're all positive and negative, okay? So I'm going to put them, you don't always have to put these because you know that you've always got the option of positive or negative, right? All right, then we've also got positive and negative, 1 over 2, positive and negative. Now 2 over 2, right, when we do 2 over 2, that gives us 1 again. We already got 1. We don't have to do it again. All right, so skip that and do 3 over 2. Positive and negative 4 over 2 is, of course, 2 again, so you don't need to do it. 6 over 2 is 3 again, and 12 over 2 gives us 6 again, which we already have. So that's great. We don't have to repeat those. All right, now put them all over 5. Positive 1 over 5, positive and negative 2 over 5, positive and negative 3 over 5, positive and negative 4 over 5, positive and negative 6 over 5, and positive and negative 12 over 5. All right, then put them all over 10. Positive and negative 1/10. Positive and negative, now 2/10 is going to give us 1/5 when we reduce it. Right, so don't have to worry about it. And now we got positive and negative 3/10. That won't reduce, that's a new one. Then positive and negative 4/10 reduces to 2/5. 6 over 10 will reduce to 3 over 5. And 12 over 10 will reduce to 6 over 5, which are ones that we already have. So here are all of our possibilities. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 possible rational zeros. All right, now looking at Descartes' rule of signs, we can determine how many sign changes we should expect and how many possible possible positive and possible negative we should have. Okay, you don't have to do this, but it just kind of gives you some help. So we start positive, we do change to negative, it stays negative, and then we change to positive again. So we know we're going to have either 2 or 0 positive zeros. Right, then we can change the signs on each of those that are odd, right? Negative 10x cubed. Of course, this one stays the same. We change up to positive 16x and then positive 12. So it's negative, it stays negative. Now we got one sign change and that stays. So just one sign change there. So we're going to have one negative. So for sure, we're going to have one negative real zero, and we're going to have either 2 or 0 positive real zeros. Okay, so let's graph the function and see where it looks like it crosses the x-axis set. Now again, we're just going to graph the part after we factored, right? This part right here, the 10x to the third, it's in parentheses. We don't need to graph the original because we factored out the x. So 10x to the third minus 15x squared minus 16x plus 12. And I'm typing all that in the exponent. Sorry about that, guys. 15x squared minus 16x plus 12. All right, so we see the graph's going to cross. We should expect it to cross at some of these possibilities right here. Looks like it's crossing at -1 and maybe 2. All right, so we can look and see if those will work in synthetic division. So let's try either -1 or 2. We know we're going to have one negative real zero. It looks like it's crossing right there at -1. So let's give that a try. -1, and we're going to use 10, we're going to use -15, we're going to use -16, and we're going to use positive 12. So bring down your 10, times -1 is -10, add those, that's -25, multiply that to positive 25, subtract 16, and that's 9. 9 times -1 is -9. All All right, so this gives us a remainder of 3, which obviously didn't work, right? We got to get it to equal 0. And it looks like it's crossing there at -1, but it must not be. It must just be really close. So let's try one of the other values. It looks like it's close. It looks like it's crossing at +2. All right, so let's try +2 now. You have to redo your synthetic division. Sometimes this happens. Sometimes we try it and it doesn't work. All right, so let's try +2. Bring down your 10. So it's 20 minus 15 is 5 times 2 is 10. Subtract your 16, and that's -6 times 2 is -12. 12 minus 12 gives us 0. Awesome. So there's one that works. 2. So we got x equals 0 and x equals 2. So there's 2 of our zeros. We got 2 more to find. Now you can keep trying synthetic division on the other option, but I suggest going ahead and trying to finish by factoring. Okay, because sometimes things work out differently than what you'd expect. So let's look at this real quick. 10x squared plus 5x minus 6. So let's try sliding and dividing. That gives us x squared plus 5x minus 60. So let's look and see what multiplies to be 60 and subtracts to be 5. All right, well, we've got, what, 5 times 12, that subtracts to be 7. You got 6 times 10, that subtracts to be 4. 3 and 20 subtract to be 17. 2 and 15, that's not it. 6 and 60 and 1 doesn't work. Nothing will work out here. Nothing will multiply to be 60 and subtract to be 5. All right, so you're like, well, what do we do then? So when you can't get it to factor, okay, you got to go back before you slid, and you've got to use quadratic formula, right? So this is something that you've done, but we haven't practiced it here yet. So what you got to do is remember what is the quadratic formula, and apply it to your function. Okay, so quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a, where a is the first coefficient, b is the one on the x, and c is the constant term. Okay, so our other x values are going to be -b, which is 5, plus or minus the square root of 5 squared minus 4 times a, which is 10, times c, which is -6. That's all over 2 times a, which is 10. So simplify. -5 right here, 2 times 10 on the bottom is 20. All right, and then we got plus or minus the square root. And one thing that's great is if you just type that straight into the calculator like it's written, it'll give you the right answer. So we got 5 squared minus 4 parentheses 10 parentheses -6, and that's 265. So we got 265. All right, now if you can simplify that square root, then you would do it. So like, maybe we can take the square root of 265. All right, now it gives me a decimal. So what you want to try to do is figure out what's a perfect square that will go into 265. So it looks like 5 will go into it. So if I take out a 5 once, and I can take out a 5 a second time, then I could factor that into square root of 5 times whatever. But look, once I take out a 5, I'm left with 53. Well, 53 doesn't divide by anything else. It's prime. So there's no perfect square that will go into 265, which means this is as simple as I can get it. All right. These are my other 2 zeros. Those other 2 places on the graph where the function crossed are at those values. Okay. So when you see right here, it looked like it was at -1. It's really not at -1. It's at -5 minus the square root of 265 divided by 20. All right. And then the other 0 over here that's in the middle, that's -5 plus square root of 265 divided by 20. Okay, so sometimes you got to use quadratic formula when it won't factor, all right? But it's something you guys have done before. You just got to bring it back and remember how to do it. So I'm going to pause this video, give you guys time to do the last one. Let me know if you have questions. All right, so on this one, the first thing you have to do is take out an x, which is great because once we get an x factored by itself, we know that x equals 0, all right? Because we set that equal to 0 and it's solved already. So that's 1, 0. Now we got to find the other 3. So we take what's left, look for our possibilities. Factors of 4, 1, 2, and 4. Factors of 3, 1, and 3. Put all those over, so we got positive -1, 2, 4, a third, 2/3, 4/3. Okay, then we graph on the calculator. Looks like it crosses the x-axis at -2. So that's probably one of the first things we should try. Let's figure out how many possible positive zeros we have. It starts as a positive value, then it changes signs once. So we know we're going to have one positive real zero. All right, and then if we change the exponents, make it 3x to the third, positive 14x, and -4. Well, now we've got one sign change and a second sign change. So that means we're going to have 2 or 0 negative real zeros. Okay, so, and you can see them right there on the graph, right? We've got 1 positive, and right here we've got 2 negative real zeros. Okay, so let's use synthetic division right here. Looks like it crosses at -2, so we can try -2. We've got 3x to the thirds. We have 0x squared, right? Remember, we've got to put a 0 in place because there's no x squareds. We've got -14x's, and we've got -4 no x's. All right, bring -3 times -2 is -6. 0 minus 6 is -6. Times -2 is 12. Minus 14 is -2. Times -2 is 4. And then 4 minus 4 gives us 0. Awesome. So we found a second 0. Right? It's -2. Now we can take what's left and try to factor. Okay. So if we did 3x squared minus 6x minus 2, we'd have to try slide and divide. So we slide the 3 over times 2 is 6. What multiplies to be 6 and subtract to be 6? Nothing. So since nothing works when we factor, we got to use quadratic formula. Quadratic formula is negative b. B is -6, so -6 plus or minus the square root of -6 squared minus 4 times a, which is 3, times c, which is -2, all over 2 times a, which is 3. So we get -6 is +6, plus or minus square root. Of course, 2 times 3 is 6 down here. And we do the square root. So we get -6 squared minus 4 times 3 times -2. That gives us 60. So square root of 60. Can we do the square root of 60? No, it's not a perfect square. It gives us a decimal. So we've got to figure out what will go into 60. So 60 divided by 2. Oh, well, that will divide by 2 again, right? Okay, so 2 times 2 is 4, right? So we can break that up into square root of 4 times the square root of 15. 15, of course, won't break down anymore. So then we've got square root of 4, which is really 2 times the square root of 15, all over 6. Now, here's the cool thing that you got to be able to do. These 3 numbers right here that are on the outside of the square root. Sorry, hold on, let me undo that. All right, so this right here, and this right here. Anytime you have all 3 of those that will divide by the same amount, you want to go ahead and divide them. Reduce that down. So those will all divide by 2. So that makes it 3 plus or minus 1 square root of 15 all over, and the 6 divided by 2 and gives us 3. So here are our other 2 zeros. 3 plus square root of 15 over 3, and 3 minus the square root of 15 over 3. All right, so we can write those up here as our other 2 answers. 3 plus and minus the square root of 15 over 3. And those are our 4 zeros. All right, let me know if you have questions, and you can go ahead and try to do these problems, give them some practice. Let me know if you need help.